Good morning. My name is Michael Madden. I am one of the NASA co-chairs for this year's DataWorks conference. It is my distinct honor and pleasure to introduce this morning's keynote speaker, Mr. David Salvagnini. He serves as the Chief Data Officer at NASA. Since joining NASA in June 2023, David's role recently expanded to include his appointment in May 2024 as the Chief Artificial Intelligence Officer. In these roles, David will yield synergies between these critical roles, especially in assuring data readiness in response to responsible and transparent artificial intelligence. David formerly served as Director of the Intelligence Community Chief Information Officer Architecture and Integration Group and Chief Architect. In these roles, he worked with the intelligence community elements and Five Eye Enterprise international partners on the development and implementation of reference architectures for interoperability, data sharing, and technical advancement of information technology infrastructure, data services, foundational AI services, and other mission capabilities. Before joining the ICCIO, Mr. Salvagnini held a variety of positions at the Defense Intelligence Agency to include Chief Information Office Technical Director, Chief Data Officer, and Deputy Chief of the Enterprise Cyber and Infrastructure Sciences Division. In these roles, David supported deployment of AI capabilities and the development of analytical tradecraft related to AI use as part of intelligence production. He was appointed to the Senior Executive Service as a Senior Technical Officer for Enterprise IT and Cyber Operations at DIA in June 2016. Mr. Salvagnini's experience includes all aspects of enterprise IT service delivery, including research, engineering, testing, security, and operations. He is retired Air Force. He is a native of Setauket, New York, and resides with his family in Falls Church, Virginia. Please join me in welcoming Mr. David Salvagnini to the stage.
Good morning, everyone. Wow, listening to my own bio sounds like I'm really qualified. Gosh, I've already made a mistake though because I don't have a 7-minute video to cut into my time. So, lesson learned for the future. The first presentation I gave when I joined NASA in 2023, the summer of 2023, was in Cambridge, Massachusetts, at a data conference. And what I did do there is I showed a video, because I was a little bit nervous about what I had to share at that point in time with only 3 weeks tenure at the agency. Okay, so it's my pleasure to be here today. I welcome the opportunity to speak and to share what we're doing at NASA with AI. And I love the fact that the prior speaker talked about data in a number of points related to that. I think it's a natural synergy when agencies look at the appointment of an AI officer to also think about data, since the saying would go something like AI needs data more than data needs AI. So if you think about that going into this presentation, that'll be somewhat of a theme, and I think there is a natural synergy. Okay, so this is just a little bit about AI at NASA. NASA always has a proud history of using AI in a number of scenarios, and I'll talk about a few of those here today. But I'll just share a couple thoughts from me. So my earliest experiences with AI, I was asked that last May at a town hall, and I talked about playing chess with a computer, probably back in the 80s. And thinking to myself, wow, that's pretty impressive. Now, was that AI back in the 80s? That's debatable. I mean, the software didn't learn. It was heavily rules-based. So really, but it appeared to be intelligent. It certainly was better at playing chess than I was. So for me, that was a computer illustrating human-like behavior. because it could outperform me, and I could also turn up or turn down the performance of the chess engine quite effectively. I don't know. I had to turn it down pretty significantly to actually be able to beat it, and even then, it was a bit rare. I wasn't necessarily a great chess player, but it certainly created a lot of curiosity about AI and the potential of AI. And I think for our public, we see so much AI around us in what we do on any given day. So here at NASA, we see that question play out on a scale unlike anywhere else. Today, I want to take you on a journey. It's a journey through how NASA uses AI, not just to solve technical problems, but to redefine what's possible when we explore the most unforgiving environments known to humanity, and how we, in every application, hold one truth constant. Innovation only matters when it's met with integrity. NASA has a rich and growing relationship with artificial intelligence. Across the agency, we're applying AI to revolutionize how we explore space, manage our missions, and expand scientific understanding. But we don't take this technology lightly. And I would add to that paragraph, by the way, we look at a lot of embedded use cases, and a lot of what I'll share here are very embedded use cases of AI here at NASA, many of which have also been adapted. But now we're into a new world order, and that is what generative AI offers. And who are the users of generative AI? And what is their skill level? And how much testing are they doing before they unleash an LLM, as part of their day-to-day work? Our approach is guided by 4 pillars: driving AI innovation to enhance mission success and scientific discovery, fostering a culture of excellence where every new application of AI is measured against our highest standards of safety, advancing AI for sustained exploration, especially in environments far beyond Earth, very unforgiving environments where mistakes are catastrophic, quite candidly, and strengthening the talent and partnerships, because we know we can't do this alone. And we, of course, at NASA depend very heavily on very rich, long-lasting partnerships with a lot of organizations and academic institutions and an entire community of citizen scientists that support our science mission. We don't just build tools, we build trust. Our process reflects NASA's commitment to explore the unknown in air and space and innovate for the benefit of humanity and inspire the world through discovery. So think about that. Think about the brand of NASA. If in any political environment, the brand of NASA is always one that is looked upon with great respect. And that's based on the integrity of what NASA does and the amount of testing, the amount of rigor, the amount of risk management, and of course, a long history of success. So let me talk a little bit about one of our successes here at NASA. And by the way, the Perseverance rover is not the first rover that has traversed the surface of Mars, but there's some interesting AI involved in that. And I want to talk to you about that a little bit. NASA has safely used AI for decades in our missions and research projects, a legacy we're proud to continue in our current and future expeditions. One of our many examples of how we harness the power of AI is the Mars Perseverance rover, which launched July 30th, 2020, on a daring journey of more than 6 months and 293 million miles. On February 18th, 2021, Perseverance landed safely on the Jezero crater of Mars, a feat heavily enabled by advanced artificial intelligence in its landing and guidance systems. So think about the amount of time it takes once that vehicle starts to penetrate the atmosphere of Mars to the point in time where it's on the surface, and think about the rate in which it's traveling. There is absolutely no way, with a communications delay between Earth and Mars, that you could effectively guide that vehicle to the surface. So it had to be autonomous, and it had to be adaptive. It had to have the ability to look at the landing environment and make adjustments in its trajectory and be able to find a safe landing spot. And of course, it did that quite successfully. But the story goes on from there, because AI didn't only enable that vehicle to land successfully, it enables the mission to this day to continue its success. From navigating the red planet's hazardous terrain to choosing samples of interest for study, Perseverance relies on AI to autonomously perform tasks and make decisions to collect, even in limited contact with Earth. This is the first mission to collect geological samples from Mars, helping pave the way for the first human missions to the Red Planet. So there's actually these canisters now that are a result of drilling into the surface of Mars to collect samples. And then in the future, there'll be a Mars sample return mission that will collect those samples and bring them back to Earth. By the way, this is not the first time that NASA has done that. We just had OSIRIS-REx, which landed in October of last year, returning a sample from an asteroid. We have another Psyche mission that's out today that's going out to Psyche asteroid, and we'll do the same thing. So sample collection and return is not new to NASA. And think about the complexity of those missions when you launch something. So in the case of OSIRIS-REx, I believe that was about a 7-year mission. From the point in time in which it was launched, it landed on the asteroid, it collected its sample, and it was able to return. And that sample was returned and is currently being analyzed. Last October in Utah, it was dropped. So interesting work, of course, but sample return is not new to NASA. And handling all the complexity of that type of a mission end to end is not new either. The Perseverance rover is searching for signs of ancient microbial life to help us understand the past climate, habitability of Mars. As of late 2024, the rover has driven 18.65 miles and collected 24 rock and dust samples as well as 1 air sample. 88% of its driving is autonomous. The rover takes images of terrain, uses its cameras to analyze those images to identify hazards, and creates routes around obstacles. It's navigating terrain that no human has ever seen. So it's interesting. So if you think about OMB and you think about the administration and some of the requirements that a CAIO has to report on AI use at a federal agency, we had in the last report to OMB 1 safety impacting AI use case at NASA. So what is a safety impacting AI use case? It's a use case where, under the prior administration's definition, any vehicle that traverses land, sea, air, or space, using any type of AI, is subject to a safety impacting use case. Because if something were to go wrong, there's potential harmful effects. So presumptively, the Mars Perseverance rover fell into that category. So we reported it as a safety impacting use case. Interestingly enough, though, the hazard, it's not like it was going to hit a pedestrian. It's not like it was going to hit someone's property and damage it. So, the risk was extremely low, but it did fall into the definition. The Mars Perseverance rover travels at less than a mile per hour. So it is very, very measured in how it traverses the surface of that planet. Perseverance also uses AI adaptive sampling to allow it to identify minerals in Martian rocks and make real-time decisions based on its findings. The rover's planetary instrument for X-ray lithochemistry instrument marks the first time AI has been used on Mars to make these types of autonomous decisions. Data from Perseverance instruments help scientists determine which samples are most likely to reveal clues of past life, so that those samples can be brought back for further study on Earth as part of NASA's Mars sample return. Adaptive sampling is not the only application of AI on Mars. About 2,300 miles from Perseverance is the Curiosity rover, which is a former generation of a rover that also is successfully running to this day with AI on board, which pioneered a form of AI that allows a rover to autonomously zap rocks with a laser and then evaluate what comes off that rock to determine its mineral consistency. It zaps with the laser based on shape and color, and then studying the gas that burns off each laser zap reveals a rock's chemical composition. Perseverance features the same capability as well as more advanced forms of AI that enable autonomous navigation and ensure resilience to Mars' harsh conditions. For Perseverance and across NASA missions, AI is a critical component of preserving mission integrity while optimizing efficiency. So we rely on AI to safeguard our investment in Perseverance. So think about, the cost of a failure on that particular platform. It's significant. It's not only significant from the taxpayer investment and the trust they put on NASA to execute our missions with with high integrity and reliability. But it's also an impact to the opportunity loss of a long duration mission like going to Mars and exploring the surface. So, unlike most commercial settings, our missions operate in extreme environments where failure isn't an option. Rigorous testing and evaluation are as important to our mission successes as innovation. So we'll talk now a little bit about data and AI. Well, I think. Okay, sorry about that. Got a little confused. I want to talk a little bit about, I'm going to go back. I think my slides are a little out of order. This is an interesting slide that I adopted from a colleague at the Department of Commerce. This is based on public use of census data. And what it does is it shows an example of different models, and it's a little dated. BART obviously is an old Google model. But it shows an example of how generative AI, in this particular case, can make mistakes and be rather misleading. So what the tester did in this particular case is they asked a number of questions, or they prompted the AI, and then they challenged, or they did the background check, fact-checking, if you will, of the responses. And you'll note that there are a number of wrong responses. Okay. So when we use generative AI, are we fact-checking? Or do we just basically accept that, well, that's the answer because the AI said it was the answer? And, why would this be wrong? So I would hypothesize that this is wrong because, one, generative AI isn't necessarily particularly good at picking the right number out of a group of papers in response to a question. But two, maybe the data wasn't properly labeled. So I go back to now the data, where AI needs data more than data needs AI. That's an absolutely critical aspect of the point in this slide is if the data is not properly marked, properly labeled in such a way that the AI understands what is the reliable source when prompted with a question like this, how can it be expected to prompt a good response or provide a good answer? So well-managed data is critical to the success of AI. And again, hence I think the reason why I recommended to the administrator after the executive order that created the role of the CAIO that it makes perfect sense that the data officer and the AI officer at least be in the same group, commingled in some way, and potentially under the same leader. And that's exactly what NASA has done. Now I'm going to go back to this other slide. So there's been recent changes from the Biden administration to the Trump administration on some of the regulatory guidance that we operate under. And I think some of that might have been spoken to a little bit yesterday. The Biden administration was very concerned with protecting privacy and rights of the U.S. public and made that very clear. It made it the centerpiece of their regulatory framework. And as such, OMB released a memo 2410 last March that called attention to that and gave very prescriptive guidance to federal agencies about how to manage the risk, in particular to public, as it relates to privacy. The Biden administration was also concerned about displacement of not federal workers, but workers in general from AI. Fast forward now to the Trump administration, and things shifted a little bit. So if you were to really kind of compare and contrast the two, the Trump administration is really focused more on acceleration. So if you read the language in the new executive order, it's less about regulating and more about accelerating. Now, what the recent OMB guidance that's just a couple weeks old has done is that it has really adapted a lot of what was in the former guidance, but changed it a bit. There's a heavy focus again on acceleration. What used to be safety and rights is now high impact AI. But there's a lot of rigor around how we test high impact AI. And I think the reality is that we have to be responsible. And whether it's AI in a Mars Perseverance rover, whether it's AI doing climate support work or studying the Earth or some other area of science, or whether it's, let's say, a budget officer at an agency using AI to create a budget report, or a personnel officer using AI to maybe evaluate application resumes, we all have to be responsible, and we have to understand what responsibilities fall to the individual user in doing so. So minimum testing practices. NASA is not a public-facing organization, so I don't process Social Security claims. I don't adjudicate education benefits. I don't handle people's tax returns, and so on, right? I'm not Department of Health and Human Services. So our risk posture is quite different than many others, because our risk is really a mission failure risk. It's really in how we embed AI into our systems. But it's also about the brand. It's also about NASA and the integrity of the work that we do, making sure that AI doesn't diminish that in any way. And that means as every employee at NASA starts to use generative AI more and more and more, making sure that they're aware of how to use it responsibly, effectively, and safely. And that means understanding how do you prepare the data. So I recently got involved in an activity at NASA where we took a large pile of data. It was input from the entire workforce, and we used generative AI to analyze the results of what we received. And one of my colleagues said, "Hey, turn AI loose and let it run its magic." And I said, "Well, AI isn't going to run its magic." So I had very dirty data, very unstructured data, and it was a bit of a challenge. So what I first had to do is I had to label it all, because I had to give the AI some context. So if you think about, okay, over 1,500 rows of unstructured data, that was, think about 1,500 people submitting ideas to an agency, with all their own framework, with all their own context, with all their own acronyms, et cetera, so on and so forth. What does AI do with that? Does AI know what DRP is, for example? Of course not. So how do I contextualize that for the AI and be able to? So there was no magic in this, over a several day effort. I would say the vast majority of that, 80% or more, was analyzing every row and labeling every row and making sure that I could cluster that data in such a way that there was some context for the AI to be able to use to come up with meaningful outcomes. Now, that was me doing that work. Okay, but does everyone at NASA understand those responsibilities as it relates to analyzing a pile of data? Well, I would say testers do. I would say engineers do. I would say scientists do. Okay, but what about everyone else? What about the folks that haven't necessarily had the opportunity to work with these kind of tools in the past on their own? Are they going to understand those responsibilities? Likely not, unless we prepare them to do so. So that's really the role that I have. And when I talk about AI at NASA, when I talk about putting those capabilities in the hands of every single user at NASA because of all the benefit associated with doing so, I also have to talk about, well, how do I prepare that workforce to be able to be responsible with that AI and help them understand, what are the responsibilities associated with the data that's maybe underpinning the AI. I'll talk about another use case now that we're excited about at NASA, and that is text to structure. So this is now a aggregation of multiple capabilities sort of brought together to now yield an outcome. Mechanical design might not seem like a flashiest part of space mission, but it's one of the most critical. Think about the weight budget of a platform that goes into space, and think about the stressors that it's under. So there's a lot of work that has to go into the structural integrity of the componentry within any system that exits our atmosphere and goes into space. At NASA, we can't just order parts off the shelf. Every mission is unique, and many of the parts are specialized, designed for mission, payload, or application. That used to mean months, sometimes years, of engineering effort involving designers, analysts, and manufacturers going back and forth between CAD models, physical prototypes, and revisions. But what if you could collapse that process into days? What if you could go from mission objectives to mission hardware in a fraction of the time? And we've proven we can. That's what we're doing with text to structure. This is an evolved AI design pipeline pioneered by our team at Goddard to take commercially available AI design tools and adapt them to NASA's needs. Text to structure allows an engineer to input the mission requirements, define off-limits areas, maybe a laser path here, maybe space for technicians' hands there, and let the AI fill in the blanks. In as little as an hour, the AI generates rapid iterations to arrive at optimized design. In a week, we can have a prototype in hand. I've seen this literally. If you take let's say a microsatellite, and you give the AI some parameters and you say, build me an X with this kind of payload capability, etc., it will build all of the structural components. It'll build the taxonomy. It'll show the nesting. It's quite impressive. The work continues. I have a component that has been printed, and we have a comparison of the human design component and the AI design component. And if you compare and contrast what those look like, the human designed one is very boxy, as you would expect, linear, bracing. It doesn't necessarily account for the fact that one brace can be smaller than another brace. When you look at the AI design, because of all the math that goes into producing it, it almost looks skeletal. It has these flowing kind of contours, and the size of each of those components is different. And then there's lightning holes as well in the structure itself. And by the way, it was designed in hours, not days, compared to the human version. And it actually exceeded the testing capabilities of the human version. So faster and more effective in the end. So text to structure started with a challenge. We needed specialized lightweight structures for a balloon-borne telescope studying exoplanets. The telescope needed to operate in extreme conditions. It had complex materials, titanium, carbon fiber, cryogenics, and tight tolerances. The AI design results called for an evolved structure, looked almost alien. However, the part was lighter, stronger, and significantly faster to build. The AI was able to create a design that reduced the part's weight from 3.6 kilograms to 600 grams, which would improve performance and reduce launch costs. But more importantly, the risk dropped. NASA standard validation software showed that these AI designed parts had 10 times fewer stress concentrations, vastly reducing the risk of failure. We now have integrated these evolved structures into more than 60 missions, including Exoplanet Climate Infrared Telescope, EXCITE, Habitable Worlds Observatory, and Mars Sample Return. And this is just the beginning. We're working with Autodesk, Synera, Zoo, and other commercial partners to scale this capability. Think about what it means to long-term missions that once took years to prepare, that could be designed and assembled in a fraction of the time, and the applications beyond Earth. With AI, additive manufacturing, and in-situ materials, we can envision a future where we build directly on the Moon or Mars, printing structures in orbit and directly deploying them in space. Most importantly, these AI-designed parts aren't just cheaper and faster to design, they've outperformed traditional design methods under the same rigorous standards we apply to every critical space asset. Now we'll talk about the Prithvi geospatial foundation model. So now the creation of a foundation model is non-trivial. So it's one thing to think about, okay, I'm going to grab someone's model and I'm going to use it and maybe adapt it to my use case. But if you're the creator of a model, and of course in the area of climate research, we've got massive amounts of data over decades, very, very complex data. The dimensions of complexity within that data are huge, and a foundational model is well suited to be able to help us analyze that. Let's shift focus from hardware that gets us into space to insights we bring back to Earth. At NASA, we manage some of the richest and most valuable scientific data sets in the world. Satellite imagery, climate records, land use patterns, environmental models, petabytes of data gathered from decades of Earth observation missions. The challenge is making sense of it all, often in time-sensitive environment. That's where foundation models come in, and one of our most exciting breakthroughs in this area is the Prithvi geospatial foundation model, developed in partnership with IBM. Prithvi is designed to do something simple but incredibly powerful. help us see Earth more clearly. Whether it's a floodplain, a drought-stricken field, or a scarred forest recovering from wildfire, Prithvi can detect these events and patterns in time for us to respond, manage, and adapt. It works by learning from NASA's Harmonized Landsat and Sentinel-2 datasets, all publicly available, by the way. These are some of the highest quality Earth imagery archives available, spanning global terrain with decades of coverage. The model is trained using self-supervised learning, which means it doesn't need labeled data. It can fill gaps in the imagery, like clouds, sensor interruptions, or shadowing, reconstructing a clear picture of Earth over time. Let me give you a few real-world examples. After major wildfires, Prithvi helps map burn scars and estimate severity, guiding land restoration and emergency recovery efforts. It supports flood mapping, tracking changes in surface water across diverse ecosystems. It helps predict crop yields and analyze land use over large regions, with applications in food security and agricultural resource management. In one application, it reconstructed imagery from cloud-covered satellite sensors using a method called multi-temporal gap imputation, giving us visibility into Earth's surface conditions that would otherwise be hidden. It's even used to detect landslides, estimate biomass, and measure ecosystem productivity. And that's just the beginning. Prithvi is open source, made available on Hugging Face so that scientists, developers, and commercial organizations can build on it. NASA benefits from the extensive support from partner organizations, academia, and a robust community of citizen scientists. NASA's scientific work is extensively peer-reviewed to assure repeatable outcomes. Like testing as part of our systems engineering lifecycle, the scientific community provides robust verification and validation as part of the scientific method. That's exactly the kind of outcome we want to see from AI. We want it to empower scientists, accelerate missions, and benefit humanity. I would also say that there's a lot of portability in this technology, because think about the defense applications of being able to, monitor the Earth, cover the Earth, and be able to see through clouds. So obviously very important work. The other thing that I think is interesting, when I was at the D&I, when we were producing our intelligence priorities, which are publicly available, for the first year while I was there in 2023, I believe, climate became an intelligence priority from the Director of National Intelligence. And why is that? Of course, food insecurity creates all kinds of other challenges geopolitically. So understanding all of these factors has many implications across our globe, not necessarily just climate unto itself. So here's another example where portability of AI. Let me check the time. It looks like I'm kind of out of time, aren't I? 12 minutes? Okay, great. And yeah, I'll go through these fairly quickly here. In fact, I'll just summarize this. I have kind of a bit of a narrative, but here's the bottom line is we had the ability, and this was developed by interns, to help with parking. So a camera and a parking lot and AI to be able to help understand, parking capacity and help guide people who are arriving at work on any given day. How do you find a parking spot? We can all relate to that. How many people have basically circled through trying to find a parking spot, and you get to the office and you're late that day, and it takes you another 10 or 15 minutes to actually find a parking spot? We dealt with that. So then NSA looked at it. Now think about the size of the workforce at NSA. Massive, right? I've been up there, and parking at NSA, unless you have a VIP pass, is not a good time. And then there are multiple other applications of this technology, because effectively what you're doing is with a camera and with AI, you're helping to inform decisions by people. And of course that has multiple applications. And what this slide shows is that we can take something that is developed and we can actually find multiple uses for it. So I'll go on to the next example, because this one's really interesting. Doc in a box. So think about long duration space travel, and think about the medical emergencies that could occur to astronauts who are on these missions. And think about, how does the crew help assure the safety of their crewmates, and deal with that medical emergency where they may have a blackout period where they can't communicate back to mission control. To achieve bolder mission, To achieve bolder missions and explore deeper than ever, NASA needs ways to support crew health and performance while navigating the challenges of medical operations in space. Currently, astronauts aboard the International Space Station rely on constant communication with Earth for healthcare needs. Our future astronauts heading to Moon or Mars will need a different kind of medical support. Enter Doc in a Box, a prototype developed by NASA and Google for leveraging AI to assess crew health and provide actionable recommendations. Doc in a Box utilizes cutting-edge natural language processing and machine learning techniques by integrating data from various sources. Rather than replacing medical experts, this system supports and increases their capability to ensure crew health and performance. Doc in a Box harnesses AI for diagnosing conditions and tailoring treatments to individual needs. Think about human anatomy in space in near zero gravity circumstances. If you were to ultrasound various organs, they're different. So if you would take a model that's able to detect an anomaly of a kidney, for example, terrestrially, and apply that in a near zero gravity scenario, that model's not going to work. So NASA has to deal with those realities, right? NASA has decades of human physiology and health data that is accumulated from our long duration presence in space. We've had a presence in space for over 25 years now, and continuous presence in space. So we have a lot of good data. Using that data as part of Doc in a Box repository to help diagnose health issues that are unique to those types of environments is what this is about. And it's an edge use case. It's really now about, okay, Doc in a Box doesn't have access to a cloud. So Google's not there, Amazon's not there, Microsoft's not there to help us. So all the power has to be on board. So it's an edge use case with well-curated data that helps astronauts protect each other in space during blackout periods or long duration space flight. So what have I missed? Aside from all the stories shared today, there's an even more powerful AI opportunity. Generative AI offers incredible potential not only for NASA, but for every organization. As such, most of my CAIO focus is on how to responsibly harness the power of AI. AI put in the hands of the entire NASA workforce in support of every part of NASA's mission is a powerful force multiplier. That said, as much potential as Gen AI offers, there's also risk. In some ways, the risk is greater since the discipline and process rigor associated with giving an LLM to a well-intentioned but potentially underprepared civil servant or contractor may create unintended harm. Some examples may include factual inaccuracies, outdated information, hallucination, misinterpretation, nuanced or complex questions, overconfidence and uncertain answers, biased stereotypes, inability to reason or understand causality deeply, errors in specialized or technical domains, ambiguity in language use, failure to recognize user intent or sarcasm, and the one I worry most about, and that is what I refer to as errors of omission. AI is beautiful at giving you an answer, and it looks quite robust, but is it complete? Did it miss anything? I've caught AI, generative AI in particular, personally, in multiple occasions, giving me partial answers. And if I were to take that partial answer at face value, I would have been inaccurate. Coming out of the intelligence community, one of the greatest fears, I think, of any intelligence analyst when they're thinking about the reliability of their intelligence assessments is, do I have all the data? And of course, in a contested environment, you don't necessarily have all the data. You have some amount of data, and then you have to assert some degree of confidence in your assessment. Well, using generative AI, you could apply that same example, that same kind of standard of tradecraft. Do I have all the data? And how confident am I? And have I actually done the appropriate fact checking as I use that AI to get to the outcome? Or do I just sort of outsource my brain and say, well, looks good to me? got to be careful, right? So I think this is the greatest thing that I concern myself with when I think about our AI journey at NASA. The generative AI capabilities are an enormous force multiplier, but when we talk about accelerating, putting it in the hands of employees, we have to also counter that with appropriate knowledge, skills, abilities, and an understanding of how to make sure that that AI is doing what it needs to do and is providing reliable answers. I say, much like cyber defense, we must equip our knowledge workers with skills and abilities to responsibly use AI and avoid the pitfalls or misuse of over-reliance. I think there's also, in aviation, I'm a pilot, there's this notion of technology complacency, where basically you can become over-reliant on the technology. Well, the technology is going to keep me safe. The technology will fly the jet. You know, the technology, as I'm backing my car out of a parking lot, will make sure I don't hit anything. By the way, I fell victim to that. I was backing the car out of a parking lot at Home Depot, and yeah, you know, the technology said everything was all clear behind me. But, you know, I forgot the fact that there was a concrete column, you know, next to the vehicle. And as I started to turn, guess what happened to the fender of the vehicle? Yep. So, you know, technology complacency at its finest, right? Because, you know, I wasn't necessarily fully, you know, I just thought, well, I'm good. I got these cameras, I got all these signals going on, and if it was a Tesla, I guess it wouldn't have done that. But that's not an advertisement, by the way. My car is like a 2017, 2018, so it doesn't have full instrumentation. It has the rear cameras, and that's about it. So I think I can stop there. You know, and open it up for questions if anyone has any questions for me.
So going back to data, you know, NASA has been around for 50 years. We have a ton of data. A lot of it's siloed. A lot of it's in different formats. What's your viewpoint with respect to advancing AI in the agency regarding putting a lot of work into cleaning up and preparing that data for AI versus simply going forward with the new data that we've got and making sure it's AI friendly?
Yeah, that's a fantastic question. Let me fast forward here. Most organizations can't afford to recategorize, reclassify, and label the entirety of their data holdings. So you kind of have to pick and choose, prioritize. But by the same token, you know, NASA, with its in the science community as an example, is a great one. Has always recognized the importance of well-managed, well-documented, well-labeled data. I remember my first couple months at NASA as a chief data officer. I joined a group of scientists, and it was the 4 key scientific disciplines in our science mission directorate, and they were getting together to talk about metadata. And they were getting together to talk about metadata not as data professionals, as scientists, because they understood the value of metadata as it related to making their science data interoperable. So this is scientists, you know, this is like a side gig for them. And they're talking about, they're getting together 3 days to work on metadata standards across those science disciplines. So they saw the value in that. But in answer to your question, I think we have to pick and choose. But I'm actually quite, I'm pleased to see that generative AI offers an opportunity there as well. Because generative AI turned loose on piles of data can help us classify it. So we can certainly train models to do that effectively. And maybe it's not 100%, maybe it's 80%. So I think that becomes somewhat of a scaling factor for us going forward. And lot of potential, as opposed to if it was 5 years ago, we would have had to have a bunch of humans reviewing all of that data, manually classifying, and of course that becomes quite the constraint. So thanks for the question. Did I answer your question? Hey.
Thanks for the talk. Hello, thanks for the talk. My name's Frank from IDA. My question is, what's next at NASA with AI, and what's your vision for the future?
So again, I would often say, either at NASA or here, that I am not worried about the scientific community being responsible with AI. The scientific community is very, very good about self-policing, and they have significant discipline in how they conduct science. I'm not worried about the engineering community in AI. The engineering community has proven time and time again at NASA that it knows how to embed computational capabilities into its platforms, to include AI, and test that rigorously and assure success. What I'm more worried about is the workforce. Okay, so really the journey at NASA is, how do I now put capabilities in the hands of employees at NASA, but equip them, as I've said earlier, with the necessary knowledge to be effective with them, to understand which AI is well purposed and well suited for a given use case, to understand when I need to ask for help, and or when I can just, let's say, have Microsoft 365 Copilot help me maybe tune a paragraph and make it a little bit more impactful, because generative AI can be particularly good at that. It's my words, so I'm the provider of the data in that particular case, maybe, and AI is just sort of digitally assisting me to make the language more impact. But it's really about the workforce. It's about 16,000 civil servants. It's all the contractors. I think another thing is as we contract with and we see more commercialization in space, are our vendor partners being as transparent as we need them to be about where AI is being used? And what is their test rigor? Or are they just assuming that it's okay to embed AI and maybe not be as transparent? So that's a bit of a concern. The other thing is if there's savings associated with AI use, are my vendor partners passing that back to us? Or how are they even incentivized to do that? Because they could just look at it as, hey, look how much more efficient we've become. But I'm responsible to get more efficient. One of the other things the Trump administration is very strong on is, organizations need to be more efficient. Okay, well, if my vendor community is also using AI and becoming more efficient, am I seeing some benefit from that as well? How you doing?
I'm so glad you started talking about the vendors because that seems to be another important risk that associated with. So, of course, everybody in this room would endorse the view that you've expressed, that AI is a powerful multiplier so long as you insist on rigorous testing and validation and so on. There's a strong pushback that in research in machine learning and AI that I sense from vendors towards the view that they can, in order to amortize the immense investments that they're making in scale, they kind of need markets to arise that believe in the fact that these things reason, that these things can achieve general intelligence and so on. And they tend to try to make that case in the absence of a lot of scientific evidence for it. And they push that case very hard. And there's a lot of pushback from those vendors against scientific research that questions the basis for those claims. So I guess I'd be really interested in hearing you say more about the extent to which maybe you experience some of that pushback and what you do to sort of ring fence your efforts from the kind of frankly scientific corruption that can arise from those commercial interests.
Yeah, no, I appreciate that. And stated a slightly different way, in my own words, I would say that there's a lot of pressure on the vendor community. It's a very competitive market space to have AI in their product in some form or fashion. So I would say there's a rush to market, and if there's a rush to market, there's potentially shortcuts. And we, buyer beware, have to be sensitive to the fact that those shortcuts could exist. And when we make our selections, when we partner with a vendor, when we think about that AI that's embedded in their product, how much confidence do we have that it's been very well tested? And are we doing our own testing and validation of that, or are we just buying it and expecting, well, it's good at what it does because the vendor said so? It wouldn't surprise me, and I've seen it already, that multiple vendors are overhyping, overselling the capability of their AI, in particular maybe some of the efficiency yields associated with those AIs. So I think it goes to, we have to have a good rubric of testing our AI, the embedded AI capabilities in our vendor products, to make sure that we can replicate what they're asserting in their marketing materials. So I don't know that I completely answered your question, but I share the concern. Right now at NASA, we have not built a portfolio that prescribes use this, use this, use this, and use this when it comes to generative AI. What we have done is we have created, I've created a climate of test and evaluate, and basically allowing, we've created some parameters. The biggest parameter I often state is you got to protect the NASA proprietary data, which means don't go out to a commercially available on the open internet LLM and pump NASA proprietary data into it and expect that you haven't basically spilled sensitive information or intellectual property. So we harp on that as a key point. But otherwise, we've allowed the workforce to do a lot of testing and evaluation with publicly available data. We will now be turning the tide and starting to apply some more portfolio discipline to how we select products that would, let's say, have an enterprise label. Something that would stand up to the fact that, okay, we have put this in the portfolio and you can count on it as being rigorously evaluated to do what it's intended to do effectively. So that's sort of, I would say, a natural progression. We created a lot of interest in AI. We want to turn the workforce loose. We have an incredibly innovative workforce, get them comfortable with using these capabilities, and now we're going to shift to a little bit more of a portfolio managed approach with very clear enterprise offerings in that space. Hey.
Good morning, Jonathan Rathsam, NASA Langley Research Center. I didn't know about the parking app, so thanks for sharing that. What applications of AI are you seeing to NASA aeronautics?
I would say when I talk to the aeronautics community about AI, certainly in the area of special alloys, structural, systems engineering. I can't personally speak to like computational fluid dynamics and where AI may be doing some work there, but certainly there's plenty of opportunity. Where I won't see it, and where I would say the aeronautics community is not particularly interested in, is turning AI loose, non-deterministic AI on, let's say, flying a jet. Now you think about a flight control computer and the fact that the box has a vote when the pilot flies the jet, that's very rules-based. And every line of code is extensively tested, right? So we're confident with that. But if you give generative AI a little bit of free rein there, we're not comfortable with that at all. So where generative AI maybe has a role in aeronautics is as a data input to a pilot that says, hey, we've noticed this, and here's a piece of information, and the pilot gets to choose whether they act upon it or not. But the AI won't just run amok. It'll always be, person in the loop, if you will, deciding whether to take that data and move forward with it. So I think aeronautics is quite conservative about how AI gets leveraged within its systems for very good reason. So I think I'm probably, yeah. So thank you very much. I really appreciated the Q&A section and appreciated all your questions. And I appreciate the opportunity to speak to you today and have a great conference. I love what you guys are doing because it's so critical to, as an Air Force veteran, seeing that video, it brought back some really good memories. So thank you so much. Have a great day.